the level of economic output. It's on the horizontal axis. So we almost always talk about the IS curve shifting left and right. The same thing is true of the aggregate demand curve. When we talk about aggregate demand curve shifts, the variable that we're particularly interested in finding out what happened to is economic output on the horizontal axis. The curve shifts to the left or to the right. So that's why, even though you could use the terminology differently, we use up and down when the variable we're interested in is on the vertical axis, and left and right when the variable we're interested in is on the horizontal axis. Okay, so there's a quick review, or maybe not so quick, review of what we did over the last couple of sessions. Aggregate demand curve, long-run aggregate supply curve, short-run aggregate supply curve. So notice we've got those three relationships. Keep in mind that behind the aggregate demand curve is the IS curve and the MP curve. So while in our diagram, we're only going to show three relationships, there are actually five. Now, when we think about this model, there's two types of equilibrium that we can discuss. One is known as general equilibrium. General equilibrium. General equilibrium is, by definition, also long-run equilibrium. So general equilibrium or long-run equilibrium can be used interchangeably. When we think about long-run or general equilibrium, the condition that must hold is that we have a joint intersection of the aggregate demand curve, the short-run aggregate supply curve, and the long-run aggregate supply curve. This is when every market is going to be in equilibrium at the same time. Okay? General or long-run equilibrium. So here's a situation where at point A, you can see that we have a joint equilibrium of the long-run aggregate supply curve, the short-run aggregate supply curve, and the aggregate demand curve. This will be general equilibrium. So since general equilibrium is also a long-run equilibrium, this particular general equilibrium, even though it's for a short-term model, can be thought of as analogous to the steady state in the Solow model. The steady state in the Solow model is where the economy goes to, and once it gets there, it doesn't leave, unless there's some sort of shock to the system. General equilibrium in our business fluctuations model is exactly the same concept. The economy will, as we'll see, will be moving towards general equilibrium. And once it gets to general equilibrium, it won't leave unless there's some shock to knock it out. So general equilibrium, wherever all three curves jointly intersect. Now we also have the notion of short-run equilibrium, right? Short-run. And our short-run equilibrium is at the point where aggregate demand equals short-run aggregate supply. Notice we've dropped off the notion that we're on the long-run aggregate supply curve. So this intersection point is somewhere away from long-run aggregate supply. We're in the equilibrium in the short run. Now it turns out this notion of a short-run equilibrium was discussed fairly significantly by John Maynard Keynes in the middle 1930s. Up until that point, when classical economists reigned, it was widely believed that the economy was almost always in general equilibrium. When it wasn't, the period of disequilibrium was relatively short, a year or two at the max, and then the economy would be back in general equilibrium. What Keynes argued, remember that Keynes was a British economist working in the 19-teens, 20s, and 30s, and 40s, but what he noticed is that Great Britain had been in a recession since the mid-1920s. Great Britain went into recession before the United States did. They had an elevated unemployment rate for a long period of time, 5 years, 6 years, 7 years, 8 years. So he said, this doesn't look like general equilibrium. It doesn't seem like it should be general equilibrium if now the unemployment rate's 15% or 20%. Do we really think the natural rate of unemployment jumped from 5 to 15% or 5 to 20%? That's what general equilibrium would have implied. So he saw that we need to think about this short run in a different way. And perhaps we can have an equilibrium in the short run that does not quickly move to a long-run general equilibrium situation. So that's what Keynes promulgated back in the 1930s, and classical and Keynesian economists have been arguing about it ever since. As I said, if they just listened to me, there wouldn't be so much controversy. Okay, so here's the situation, point A, that is clearly a short-run equilibrium. Right? It is the intersection point of the short-run aggregate supply curve and the aggregate demand curve. It might also be general equilibrium, but it would only be general equilibrium if Y naught was also potential output. But it's easily possible for potential output to be below Y naught, or for potential output to be above Y naught. In which case, point A now becomes short-run equilibrium, but not long-run equilibrium. And what we then need to figure out is, okay, if we're at point A in a short-run equilibrium, but not general equilibrium, how do we get back to general equilibrium? Remember, in the long run, we're going to end up with complete wage and price flexibility, which means that wages and prices will adjust so that all markets are back in equilibrium simultaneously, which tells us we would be back in general equilibrium. So we need to think about, if we're in short-run equilibrium but not general equilibrium, what happens? And that's something that we refer to as disequilibrium dynamics. If we're not in long-run equilibrium, how do we get there? So let's start with thinking that economic output is above potential. Economic output is above potential. So here's the situation. Right? So I drew a short-run equilibrium at point A, where economic output is at Y1, and inflation is at pi 1. We are not, however, on the long-run aggregate supply curve. Economic output is above its potential level. So we have to figure out what's going to happen next. Now, in order to do this, we need to determine one other piece of information. For this particular short-run aggregate supply curve, we have to know, now notice in this particular short-run aggregate supply curve, it tells us that expected inflation is equal to pi naught. But when I look on the vertical axis, I don't see pi naught. So the first thing that we would want to do is figure out where pi naught should be. Keep in mind, when expected inflation equals actual inflation, is a long-run equilibrium condition. When expectations are being fully met, we're in equilibrium. That's where we would be on our long-run aggregate supply curve. So we want to look then at our short-run aggregate supply curve, where it intersects the long-run aggregate supply curve. This is the only point where expected inflation can equal actual inflation. In this case, pi naught. Now notice that is not what inflation actually is. Inflation's at pi 1. But to be in long-run equilibrium, expected inflation has to equal pi naught, which is the intersection point of the short-run aggregate supply curve and the long-run aggregate supply curve. Great. So what? Does that help us determine what's going to happen next? So in terms of thinking about what happens next, let me write two equations. Inflation in any given year equals the actual rate of inflation the prior year times some parameter times the output gap plus any price shocks there may be. That's the equation for our short-run aggregate supply curve. The second equation, is our one period, or in this case 1 year, adaptive process for expected inflation. So in working with this model, let's just always assume that a time period is a year. So we can always talk about year 1 or year 2 or year 3. We don't have to worry about anything else. Okay? So what we see then is expected inflation in year 1 is actually equal to actual inflation in year 0, which is what our short-run aggregate supply curve shows us. So let's think then, what happens in year 2? So the first thing that we can see is that in year 2, expected inflation in year 2 is going to equal actual inflation in year 1. Actual inflation in year 1 was pi 1. We've now had a change in expected inflation. Right? Expected inflation changed from pi naught to pi 1, from 3% to 4%, 4%, 5%, whatever the numbers are. So what do we know if there's a change in expected inflation? Short-run aggregate supply curve shifts up. So we know the short-run aggregate supply curve is now going to shift higher. How much higher? The other thing that we know, expectations will be fully realized only in the long run. So if expected inflation moves to pi 1, then that means the short-run aggregate supply curve has to intersect where pi 1 is at the long-run aggregate supply curve, right at that point. So the short-run aggregate supply curve shifts up to that point. Those are supposed to be parallel lines. So this is our short-run aggregate supply curve in year 2 with an expected inflation rate of pi 1. Now notice, before inflation does anything, notice exactly where we are. So people are expecting inflation of pi 1. Businesses are. Right? The short-run aggregate supply curve says, if that's where we expect inflation to be, this is how much we want to produce. So at an inflation rate of pi 1, we want to produce this amount. But notice at that inflation rate, buyers, consumers, businesses, governments, foreigners, want to buy a higher amount out at y1. We have excess demand in the economy. How do we observe this? When there's excess demand, we should see inventories falling. This is a pretty good signal for businesses to increase production. In order to increase production, businesses need to hire more workers, have more inputs. In order to attract those additional workers and inputs, they need to raise prices. As they raise prices, the inflation rate begins to rise. Notice as the inflation rate rises, businesses are more comfortable producing a bit more. The actual inflation rate, which you can think of as their selling price, is rising above their expected inflation rate, which is easy to think of as your cost structure. So if selling prices are rising relative to my expected increase in cost, profit margin should be rising. I should be willing to pay more, produce more, excuse me. Now, at the same time, as inflation is rising, the central bank will be raising the real interest rate along the monetary policy curve. As the real interest rate rises, the cost of borrowing increases. Borrowers borrow less. Therefore, spending will go down. There'll be a movement back along the IS curve and a movement back along the AD curve until we get to point B. Now, notice that at point B, inflation is higher. We're now at pi 2. But also notice that at point B, economic output is now coming back towards potential. Back towards potential. Why is economic output falling from y1 to y2? Higher inflation leads to higher real interest rates along the monetary policy curve. Higher real interest rates leads to less borrowing, less expenditures, a movement back along the IS curve, and less economic output. So here we are at in year 2 at point B, inflation at pi 2, economic output at y2. We're in short-term equilibrium. Notice, however, we're still not in long-run equilibrium. So in year 3, the following time period, what happens? Expected inflation in year 3 becomes actual inflation from year 2. Actual inflation in year 2, that gives us our base. Expected inflation has changed. The short-run aggregate supply curve will shift up further. And we go through the whole process again. Notice that demand in the economy, with inflation at pi 2, demand in the economy is at point B. But producers only want to produce where the short-run aggregate supply curve intersects the long-run aggregate supply curve at potential output. Again, there's excess demand in the economy. That excess demand is going to cause prices to rise. As they do, businesses will be willing to produce more. Consumers will want to consume less because of higher real interest rates. We move to point C. Inflation has gone up again, and economic output has come down. Notice that economic output seems to be returning to potential output. Now, here's the question. Inflation rose between year 1 and 2, right? We went from pi 1 to pi 2. It also rose between year 2 and 3, right? Pi 2 to pi 3. In that second year, or in the third year, when it went from pi 2 to pi 3, was that a bigger increase, same size increase, or a smaller increase than the rise in inflation from pi 1 to pi 2? Are you saying that because that's the way I drew it, or are you saying that because you know that's the true answer? How do you know that's the right answer? Why would inflation rise at a slower pace between years 2 and 3 than between years 1 and 2? That's one interesting way to think about it. Okay. Anything else we could say? I'm sorry? Price leaky? Oh, sticky? No, that's not quite. You're closest. Anybody else? Yes? Right. Let's look at the inflation equation. Right. This is what tells us what inflation is. What we know from this equation is this output gap keeps getting smaller. So the upward pressure from the excess demand in the economy is getting smaller and smaller. So the upward push on inflation is also getting smaller and smaller. Now, where do we end up? So clearly, point C, short-term equilibrium, but not general equilibrium. So this process will continue. But notice the steps are getting smaller and smaller. Eventually, the short-run supply curve will move up until it intersects the long-run aggregate supply curve at the point where the aggregate demand curve intersects the long-run aggregate supply curve. This is a point that I call N. Not because I think it takes that many time periods to actually get there, but because this is the end point. Okay, at least grown. Come on. So, notice what happens at point N. The first thing that occurs once we get to point N, the economy has returned to potential output. We're back in general equilibrium. The second thing to notice is inflation has stopped rising. We have a higher inflation rate than when we started, but once we get to pi N, it doesn't change anymore. We are now in general equilibrium. Everything's stable. Economy is at potential output. Inflation is steady. The unemployment rate then would be at the natural rate of unemployment. What a mess. So I hope on your exams and problem sets you'll draw much more cleanly. Not for me, but for the GSIs. They're all down here saying, yeah. Okay. So that's how, if we start out of general equilibrium, we get back to general equilibrium. Okay? This is that dynamic that we have. Notice that this is a different process, but in some sense it has the same kind of underlying logic to it that we saw with the Solow model. If we weren't at the steady state, there were natural economic forces that would drive us back to the steady state. Here, if we're not at general equilibrium, there are natural economic forces, in this case operating through a difference between actual and expected inflation, and those changes in expected inflation driving the economy back to general equilibrium. Now, let's think about the opposite situation. Suppose the economy starts below potential output. Right? Below potential output. So now we're at point A. Oh, there was one other thing I wanted to show you. Okay, one other thing on, let's see, I need another color. Oh, purple's always a good color. So let's think about starting here and finishing here. And if we wanted to show the path that the economy traveled, the scatter plot, if you will, of output gaps and inflation, notice that what we would see is something like that. That the adjustment mechanism is first to a big output gap, then to rising inflation, and then the output gap comes back. So it's this counterclockwise move, if you will, from basically 6 o'clock to 12 o'clock. This will be important because we're going to look at some of these kinds of squiggles on Tuesday, and knowing what the squiggle should look like will have a certain amount of information for us. Okay, now let's go back to our new situation.